All right, let's go ahead and go over the warm-up. So we have a situation in which you've got $100, and you're going to use it to be able to place money on making some bets. And I want to know how much would you bet based off of these different events. So given $100, if you want to think logically, thinking about the situation and a logical placement of a bet, how much would you bet that you're going to land on tails if you flip a coin? So remember, a coin has how many sides? 2, right? It's got tails for one side, heads for the other side. So logically speaking, if I've got $100 and I want to bet money that's going to land on tails, how much money should I bet on that? Because you're so funny. It's like you guys are so loud, and then when I ask you a question, how much would you bet? $50. Why would you bet $50? Angel? Because it's half of 100, right? If you've got two different outcomes. One of those outcomes is tails and the other one's heads. That means you've got a 50% chance. A 50% chance of landing on the outcome you want. So 50% of your money should be bet. Okay, because you've got a 50% chance of not only getting that $50 back, but getting an extra. So thinking about the probability of the event should dictate your bet placement. So we're going to say $50 because, again, it's 50% chance that you're going to land on tails. Okay, let's take a look here. Spinning a spinner. So we've got this colored spinner with orange, blue, pink, and green. I want to spin the spinner and I want it to land on pink. How much of my $100 do you think we should bet on landing on pink, Robert? Why? Okay, so 25% chance that we're going to land on pink, right? 1/4. Right, we know how to split up quarters, right? 1/4 or 1/4 of the spinner is going to be pink. So a quarter of $100 is $25. Very good. So $25 would be the logical bet. Okay, rolling a number cube and landing on a 7. Rolling the die and landing on a 7. Joseph, what do you think? How much would you bet out of $100 that you're going to roll the die and land on a 7? How much of your $100 would you bet that you'll land on a 7 if you roll this die? Huh? $50? You're going to bet $50 that you're going to land on a 7. The calculator ain't going to help you, honey. Is he going to win $50? Why not? Because there's no 7. There's no 7. Hey, Joseph, there's no 7 on here. So do you want to bet any money at all? No. So you should say 0. $0. You don't want to bet any money. Hey, hush. Amir, how much are you going to bet for the 4th one? Rolling it and landing on a number less than or equal to 6. Great. That's not what I asked, though. Number less than or equal to 6. How much of your money are you going to bet then, Amir? $10. That's it. Man, Amir, I'm going to bet up against you and Joseph because I'll win all his money and you won't win any very much. Julian, how much of your money would you bet that you're going to land on a number less than or equal to 6? All your money. Because guess what, guys? Every single number on here is less than or equal to 6. So are you guaranteed to win? You are guaranteed to win. See, Amir, when you make fun of somebody for their answer, I call on you so we can make fun of yours. But like, well, Amir, honey, you got to read with everything, dear, but you didn't do that either. So the idea of probability, guys, you see probability all the time. Whenever you look outside, or if you hear, oh, for instance, here we go. This is a good one. 2 weeks ago on a Friday, it was supposed to snow. Remember, we were all hoping that maybe the school would get canceled. And as we kept getting closer, everybody's like monitoring what it says is going to happen. And you're looking at it and going, okay, hey, right now, Friday, it says it's like a 60% chance that it's going to have like icy conditions. Ooh, that means 60% chance that we probably won't have school. But then as we get closer, the percent gets smaller and smaller. That's probability. So you guys are looking at that, and it's the probability. When you know what your weather is, it's the you're using weather as a way to predict or make an assumption of what you should wear that day. You're using probability then, okay? And probability is all about likeliness, how likely an event is going to happen or not happen. So here, let's go on to the next page. We're going to just start with very simple, basic idea of probability. Most of this should be a review to you, because I was looking back over your 5th and 6th grade skills. This, again, to be a probability review, but you need to understand terminology. To flip your paper does not mean you have to run your mouth. You have to understand your vocabulary. If you don't remember your vocabulary, it's going to be a little bit more difficult. Something as simple events might be a little bit more difficult if you don't remember to review your vocabulary. So the first term that you have to understand with probability is the idea of an experiment. All probabilities are based off of events or experiments. Okay? So the experiment, it's just a basic activity that involves chance. A basic activity involving chance. And honestly, guys, everything in life is involving chance. When you get into the car, there are probabilities of whether you might have an accident or not. Hence the reason that they get these statistics of you're more likely to get in an accident 5 minutes away from your home than you are to not. Or to get into an accident elsewhere. Okay, so these are all chances, things that when you get into the car, you're taking a chance that you're going to get to your destination in one piece. Okay, when you take down your mask, you're increasing a probability of what? Getting sick. Not even just COVID, but maybe catching the flu. Okay, it's cold and flu season too. When you do that, you're increasing a chance. You're increasing your probability. Doesn't necessarily mean that it's going to happen. So maybe right now having a mask on and me standing next to somebody who has a mask on, probability of me catching COVID from them if they have it is like 5%. But if I remove my mask, I've now increased my chances to 25%. If they also remove their mask, I've increased my chances up to like 85%. Those are all probabilities. It's all about chance, basing something off of an event that involves chance. Now, the events that we'll be talking about, or the experiments that we'll be talking about, are more things like you're going to, roll the die. You're going to flip a coin. You're going to spin a spinner. We're going to be focusing on those basic ideas of experiments. So let's go ahead and write that as an example. So an example of an experiment is to just go ahead and roll the die. A trial. A trial is the repetition of your experiment. So repeating a process over and over and over again. So for example, if I roll the die, if I roll the die 10 times, That's going to be 10 trials. Okay, how many times I perform my experiment is going to be the number of trials. The amount of times that I'm performing my experiment is going to represent the number of trials. If I flip a coin 100 times, that's 100 trials. Your outcomes. When we're talking about outcomes, we're talking about possible results for an experiment. All the possible results. Of an experiment. Okay, so again, let's focus on the die. All the possible outcomes. You've got 6 outcomes. Right? It could land on a 1, a 2, a 3, a 4, a 5, or a 6. Those are all your possible outcomes. It's important to know how many outcomes an experiment has, because probability is out of a total. And that total is depending on what the experiment is. Do I have the same number of outcomes for a die as I do for a coin? No. So that means the probabilities are going to be different. The probability of only one of these outcomes occurring on a die is 1 out of 6. The probability of only one of the outcomes occurring on a coin is 1 out of 2. They're different. So probability is always based off of a different total depending on whatever your experiment is. And it's the same thing here. Like, if I decide to use you guys for an experiment and say, okay, I want the probability that I'm going to call on a girl in the class, the probability of me choosing a girl in this class is going to be different than the probability of me choosing a girl in my next class, because they have a different number of girls than you do, and they have a different number of total people than you do. Your class size, if everybody's here, which they're not, but if everybody were here, you'd have a class size of 34. My next class does not have a class size of 34. They're at 26. So they're smaller. So their total is different, which in the long run then changes the probability itself. Okay? All right, an event. When we're talking about a specific event, it's a set of one or more outcomes desired or achieved. We'll go with achieved. It's a set of one or more outcomes that you are trying to achieve. So again, sticking with the die. If I roll a die, and I want to land on the number 3. I'm rolling the die and I want to land on the value 3. That's the event. And the way that we showcase that, this is how it would be written. We would write P for probability, and then in parentheses, we would put down what event we're looking for. So if I write P and then roll a 3, P and then roll a 3, this means I want the probability of rolling a 3. I want the probability of rolling a 3. That's just the shorthand way of writing it. So get used to seeing this, because this is what you're going to see often on your assignments, on your quizzes, tests. This is how they'll write it. P stands for probability. Parentheses represents around the event that you're looking for, the specific event that you want. Okay, and then the last thing is the idea of probability itself. Probability is just a measurement of likelihood. All it does is it measures the likelihood that a specific event will occur or not occur. There is such thing as the probability of something not happening. We call those complements. And we'll talk more about that in a little bit. So it's the measures of likelihood that an event will occur. All right, so when we are doing this, it's an understanding, so that the term likelihood, it's an understanding that there are specific terms that relate to specific probabilities. So just like in our rationals unit, we had a number line. Here in probability, you have what's called the likelihood number line. But it has very finite or defined starts and finishes. It's not an infinite thing that goes on forever. It has a starting point at 0 and an ending point at 1, because probability has a range, and that's something that you need to understand too. It ranges from 0 to 1 or 0% to 100%. That is the range of probability. It cannot be any less than 0. It cannot be any greater than 1 whole. Or if you're putting it in percent form, the smallest percent is 0%, the largest percent is 100%. So let's go ahead and talk about these ranges. So like I said, probability is very finite. It has a very defined starting point and a very defined ending point, meaning you can't go higher or lower than those points. You can write probability as a fraction, so I can write it as 0 all the way to 1 over 1. 1 over 1 would be a fraction of 1 whole. I could also write it as a decimal, so I could start at 0 and go all the way to 1.0. Or I could write it as a percentage. I could start at 0% and go all the way to 100%. Does anybody still need this line right up here? Because I know that I see that some people are having to stand up in the back to see. And I don't want you to have to keep doing that. Sorry, Roberto. Okay, so we have these as our finite starting and stopping points. Halfway in between, who can tell me what falls halfway in between 0 and 1? Nicholas? That's okay, you can still answer. What's halfway between 0 and 1 whole? I just told you. What's halfway between 0 and a whole? What's halfway between 0 and a whole, Jenna? 50% or 0.5, or what would that be as a fraction? A half. Halfway. I'm sorry, Nicholas. Halfway between 0 and 1 is a half. You have a half. 1 over 2 or 0.5 or 50%. 50%. Okay? In between 0 and a half. Does anybody know what's between 0 and a half? Denim? 25%? Okay, so there's our percentage, 25%. What is that as a fraction or as a decimal, Braxton? Not a third. Angel? A fourth. 1/4. Think of it, quarter, right? A quarter. 25% or 25 cents or 0.25. Okay? And then on the other end, between 1/2 and 1/2, or 50% and 100%. EJ. Not 1/8. We're going between 1/2 and 1/2. Angel? 75%. 75%, which is 0.75, or as a fraction, it is 3/4, 3/4. Okay, so this is the basic idea of the number line. There is a defined verbiage that is used with each of these. So let's start at the very, very back at 0. I'm going to highlight this in pink, and notice I'm highlighting straight down. There's a point for that. There's a reason. I'm highlighting straight down at just this point. I'm letting you know that only 0 or 0% is being included in this, and we call this position right here impossible. This position right here is labeled impossible. The reason it's labeled impossible is because if it's got a 0% chance of happening, that means it is impossible for it to ever happen. So just like with before, when I said, hey, how much would you bet that I'm going to roll the die and land on a 7? That's an impossible event. It cannot occur because none of these numbers are 7s. So we would label that as 0% or 0. Or if they're asking for likelihood, you would call it impossible. Okay, we're going to go straight to the center now. Straight here at the center mark, I'm going to go ahead and highlight all of this in blue. I'm going to highlight all that in blue. And again, this very specific value, of 1/2 or 0.5 or 50% is labeled equally likely. Equally likely. Sometimes it's called equally likely as not, or as likely as not. Equally likely, though, is the terminology. What this means is that you have just as equal of a chance for the event to happen as you do for the event to not happen. So like with the quarter or the coin, you have an equal chance of landing on heads as you do to not land on heads, because there's only 2 outcomes. So that's where you get that 50%. If the probability is exactly 50% or 1/2, we call that equally likely. It has an equal chance to happen as it does to not occur. Okay, then all the way at the very right end, at 1/2 or at 100%, this event is titled certain. This is titled certain. Today is Thursday, so I am certain that tomorrow is Friday, because the probability that tomorrow is Friday is 100%. If I know that today is Thursday, there is no way that I can get to tomorrow without it being Friday. Those are certain events. Can you two stop talking? So these three are very specific. They can only be called that if it's an exact value. I can only say impossible if it is exactly 0. I can only say equally likely if it's exactly at 1/2 or 50%. I can only say certain if it's exactly at 1/2 or 100%. These other two categories are ranges of events. So if I have a probability that is greater than 0, but it's less than 50%. It's greater than 0, but it's less than 50%. We call this entire range here unlikely. So I'm not even going to highlight just this because it's not a specific number. It's a range of numbers. If my probability is 0.000000001, that's unlikely. It's extremely unlikely, but still unlikely. Just the same as if it's 0.49999999999, that's still unlikely. It's not exactly 50%. And the same goes for here. Anything that is greater than 50%, but is still less than 100%, greater than a half, but less than one whole, we call that likely. Okay, it has an entire range. So there's only 3 of them that have to be very specific values. The other 2 can be a range of values. When you've got that down, flip to the next page. All right, for these next set of problems, what you're going to do is you're going to determine whether the following events are impossible, likely, unlikely, equally likely, certain. So that means that you'll have to identify what the probability is first, and then describe the terminology. Okay, so you're going to describe if it's likely, unlikely, equally likely, impossible, certain. So again, like I said, when we talk about probability, we just use shorthand methods of writing it. We're going to put P, so that's probability of rolling an even number on a number cube or on a die. I want the probability of rolling an even number on the number cube or die. So when we set the probability up, the probability, like I said before, it's most commonly written as a fraction. So you guys got to get used to that. We use percentages, yeah, we use decimals, but the most common way of writing a probability is in fraction form. So you need to make sure you get used to that process. So the way that we set it up is we identify the event that we're looking for, and we calculate how many ways can that event occur, and we put it over the total number of outcomes. So we identify how many ways can my specific event occur out of all total outcomes that that experiment has. So here, when I want my event to be an even number, that's what I'm looking for. My event is to get an even number on the die. What numbers on this die are even. 2, 4, and 6. 2, 4, and 6. These are the specific numbers I'm looking for out of the total outcomes. So my total outcomes, I'm just going to list out what my outcomes are. I could land on a 1, a 2, a 3, a 4, a 5, or a 6. So right now, this is not what you have to do. This is me showing you. This is just me showing you where we get our values from. So to get an even number, there are 3 ways. There are 3 ways that I can get an even number. So the probability of getting an even number is going to be 3 out of, how many total numbers do I have? 6. 3 out of 6. Now, like with any situation, when we're dealing with fractions, can I leave it like this? No. Why not? Because it's not what? It's not simplified. It's not simplified. You always want to simplify. Okay, and you can do that. You can do it in your head, or you can even type it in your calculator. You can use your calculator, hit your fraction button, put 3 over 6, and hit enter, and what should it give us? 1/2. Because we know that both of these are divisible by 3. So the probability is 1/2. So now I need to go back to my number line, don't I? Looking back at my number line, which probability up here represents 1/2? Which one of these? Nicholas? Equally likely. Equally likely represents that 1/2, okay? So when they're asking for my likelihood is going to be equally likely. So to land on an even number on the numbered cube, I have an equally likely chance of it happening. Let's try another one. We want the probability that this time we're just going to roll a 5. I just want to land on a 5. Okay, so I'm going to roll it, and it lands on that 5. That's all I'm wanting to try to get to. So in order for that to happen, again, I need to identify how many ways my specific event can happen. So the event that I'm looking for is to land on the number 5. And I'm going to put it over the total number of outcomes, which again, we already said was a 1, 2, 3, 4, 5, or 6. Okay, so how many ways can I land on a 5? 1. There's only 1 5 on here. There's only 1 5 on here. So that happens 1 time out of 6. Well, I can't simplify that any further. 1/6 is as simplified as it gets. So looking back at my number line, which category does 1/6 fall on? Is it 0? No, so it's not impossible. Is it 1 whole? No, so it's not certain. Is it a half? No, so it's not equally likely. So we have to decide, is it going to be in the unlikely range or the likely range? Unlikely. Unlikely. It's smaller than a half, but greater than 0. So this is going to be unlikely to occur. Still has a chance to happen, just not that great. Like almost a 17% chance of happening. Okay? I want the probability that I'm going to choose a vowel from the alphabet. Probability of choosing a vowel out of the alphabet. So again, we're going to identify the specific event. We're identifying the specific event. What letters are the vowels? A, E, I, O, U. Good. A, E, I, O, U. There are my vowels. How many are there? 5. Just 5 of them. My total, what do you think is going to represent my total? So if my event was the vowels, what's the total going to be represented as? How many letters there are, right? So all the letters. Who knows how many letters there are in the alphabet? 26. 26. There are 26 letters in the alphabet. And hey, guys, don't pick on anybody because some people come from another country where the amount of letters in their alphabet is different than what's in ours. Okay? So 5 out of 26. 5 out of 26 for the American alphabet. Okay? All right. What kind of probability is that? What likelihood? 5 out of 26. Unlikely. Unlikely. It's less than half. And in case you're unsure, if you're not too sure about it as a fraction, guys, you could easily just type in 5 over 26 into your calculator, and then you can hit that conversion button down at the bottom, and it converts it into a decimal, and then you get 0.19. Well, we know if it's 0.1, that's less than a half, isn't it? 0.1, 0.2 would be less than a half. So this is going to be less than a half, so we know that that's unlikely. All right. Probability that we're going to have this lovely little spinner here. There's orange. We've got green, green, green here. We've got blue, blue, and then I'll have a pink. Okay, so here's my lovely little spinner here. I want the probability that it's not orange. I want the probability that I'm going to spin the spinner and it's not going to land on an orange. Okay, so again, the specific event that I'm looking for, if I do not want it to be orange, then what will be okay? If I don't want orange, what will be okay then? Green. Okay, green would be okay. Sure. What else? Blue. What else? Pink. Okay. How many greens are there? 3. How many blues are there? 2. How many pinks are there? What do you think I should do with those numbers? Add them. So I should probably add those together, which means I've got 7 ways to not land on a orange piece. And then out of the total, that's going to be all the sections, right? All of the sections, all the colors, which is 8. 7/8. What's the likelihood? Likely, right? It's larger than a half. It's likely. Try this one on your own. Don't oh no. Probability that you're going to choose a month that ends in the letter R. You're going to choose a month that ends in the letter R. Tell me what they got. How likely are we to choose a month out of the year that ends in the letter R? Tony? Not impossible. Amir? Unlikely. How many months end in the letter R? 4, right? We've got September, October, November, and December. That's 4 months out of the year. Okay, so that means all months. How many are all the months? There's 12, right? 4 over 12. If you type that into your calculator, that simplifies to 1/3. And 1/3 is an unlikely probability. That's an unlikely probability. Now, I still have one more thing that I want to show you guys real quick. So flip to the next side. We're going to be like 2 minutes over. Go to your next one. The complement. The complement. When we talk about complement in probability, that's going to be set of all outcomes that are not the event. So basically finding the probability that a specific event will not occur. So whenever we see chance of rain, we're like, oh, okay, 22 chance of rain. I don't need to bring my umbrella because it's likely to not rain. Okay, when you're looking at a probability, a lot of times people view the probability and they're assuming the complement, which is that it will not happen. So let's go with that, what I just said. If I say the probability that it's going to rain is equal to 22%, I want to know what is the complement, which essentially means what's the probability that it's not going to rain. So to find the probability that it's not going to rain, remember probability is out of one whole or 100%. So if I take 100%, and I subtract, I'm trying to think of a different color that I can use, but I don't have one. If I subtract that 22% away from it, that's going to give me 78%. So 78% would be the complement. Now, again, it's not always going to be in percentages. It might be in a fraction form. So the probability that I'm going to roll a 5 or a 6, do not pack up yet. The probability of rolling a 5 or a 6 is 1/3. So if I want to know what is the complement, I want the complement. Again, because it's in fraction form, I need to take a fraction whole, so 1 whole, and I'm going to subtract the probability that the event does happen. So I'll do 1 whole minus 1/3, and that's going to give me my complement, 2/3. So it's a 2/3 chance that I will not roll a 5 or a 6. Now you may pack up.